Welcome to kinoinstrument.com. Please like, share, subscribe my video. Today we're going to look at a process called cracking. The word cracking tells you exactly that it means you're going to crack something, you're going to break something. Now in the previous video you have already knew that the hydrocarbon is actually came from the crude oil. So the crude oil will have different sort of fractions. So the hydrocarbons can be alkanes and alkenes. And if you see my previous video, I've already explained that alkanes and alkenes are the two types of hydrocarbons you're required to know in GCSE. The formula for alkanes are CH4, C2H6, C3H8, based on the general formula which is CnH2n plus 2. Now N is actually the number of carbon atoms. Methane has one carbon atom, so you put one there and then you put one there as well. So the formula for methane will be actually CH4. And then we have ethane. At means 2 carbon atoms and prop means 3 carbon atoms. So if you put 3 here and 3 there, it will come as C3H8. Now, alkenes, on the other hand, the general formula is CnH2n. Now, if you do not remember this general formula, the number of hydrogen atoms are going to be double than the number of carbon atoms. So you will have the smallest alkene, you have C2H4, and then you have C3H6 and C4H8. So hydrogen number is double. You put 2 there, so C2H4. Now, the difference between both of them is if you open the molecule, let's just say we take ethane and ethene. If I try to open this molecule, as I said before, you draw carbon first. For this as well, I draw carbon like that. You will have 6 hydrogens. You will put 6 hydrogens around it, and that will give you the formula. Here, alkanes has carbon to carbon all single covalent bond. Alkenes have carbon to carbon double covalent bond. That's the difference between them. Each carbon atom can have only 4 bonds. So based on that, each of carbon atom already got 1 bond, and the rest of the 3 bonds will be the covalent bond with hydrogen. The alkanes, because there is only carbon to carbon single bond, it is called saturated. So in GCSE, if they ask you what is saturated hydrocarbon, you can say when they have carbon to carbon single covalent bond. Here you have carbon to carbon double bond. Each carbon atom already have 2 bonds. Carbon is in the 4th group. It has 4 electrons in the outer shell, so it can have only 2 more bonds. That means each carbon can have 2 more bonds. So 2, 3, 4, each carbon has 4 bonds now. Now these 2 bonds, you put hydrogen there, and that will be the formula of ethene C2H4. Now when you actually have this, you have crude oil, and crude oil has got a big molecule as well. For example, you can have C10H22, which is called decane. Now, decane or C10H22 is a large hydrocarbon, and C up to C5 or C6 or C7 is like petrol and diesel, and that they are very, very in demand. So the C10 or C12 or C32, the large hydrocarbons are not in demand in the market. So what are you going to do with them? Because every time you're going to do fraction distillation, you will be actually producing them along with them anyway. So you can have a C20, H42, like a big large hydrocarbon. So what are you going to do with that? Because if you produce thousands of liters, millions of liters every day, and your demand is actually not high. You have to store it somewhere, and we do not have space to store all of that. So what scientists came up with an idea is called cracking. So you're going to crack it, to break it. Now if I would like to draw this formula, this is C10H22. Now C10H22 is actually an alkane, and what's going to happen is in this process you're going to actually crack it. So if I will crack it, I have to use steam, and I have to use a catalyst. Catalysts are chemicals which helps to speed up the reaction and chemically unchanged at the end of the reaction. Now you see that if you're gonna put a C10H22 there, you're gonna put the steam and you're gonna put the catalyst in there, and you heat it up, and these are steel made containers. So you put the large hydrocarbons in there, you heat them up, mix them with the steam and the catalyst, and they will be thermally break down. So with the thermally decomposed or thermally break down, so this will be converted into C5H10, and then you have C3H8, and then you have C2H6. Now this one, when you have double the number of carbon atoms, that is an alkene, because because there are 5 carbon atoms, so that will be pentene. This one 3 carbon atoms, and that's propane, because it actually exactly same like here C3H. It is not double, it's double plus 2. And here you have ethane, because it cannot be called as ethane as it is C2H6. Once you got that, you have C10H22. You cracked it, so large hydrocarbon like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have decane, and these are the hydrogens. You use steam and catalyst. And you're going to break it 1, 2, 3, 4, 5. So the chain will be broken down from here, and I will actually write it down in red so you have distinguish from them. So you have 5 carbon atoms, and you have 2 carbon atoms, and then you have 3 carbon atoms. That's why you have C5H10, then you have C3H8, you have C2H2. So that will produce all of them. Now in GCSE exam, this is how we're going to give you. What if they give you C30 and H62, and they will put this one there? They said you have C10 and H20 is one of that product. If they ask you to complete this bit, you should be able to do that by actually minus the number of the carbon atoms of one of the products. 30 is a starting material. This is your large hydrocarbon. 10 is one of the products. How many carbon atoms are left? 2. 20. So you put there 220. Now you need to figure that out. This is very technical. One of the products should be an alkene, and the second product should be an alkane. So you should get one alkene all the time. So this one is an alkene. You can see it has double the number of hydrogen atoms as compared to carbon. So this is actually an alkene. So you have an alkene. The other product should be an alkane. So you will actually look at this formula CnH12 plus 2. So C20, I cannot put 40, I have to put 42. If you add them together, for example, if they give you the reverse question and they remove this and say complete the starting material, all you have to do, you add the carbon atom. So you will say C30 and H is 42 plus 20, 62. So in any case, if they ask you to do that, you can do that. Now, if it is a 1 mark question, can you actually define what is cracking? So you're going to say the breakdown choice question, then you will be writing like this. Cracking is actually also called thermal decomposition. So you need to remember that a question can be a definition, or it can be a thermal decomposition, or the alternative name of cracking is called thermal decomposition, because you use a heat, steam and catalyst which actually breaks down the large hydrocarbon, using catalyst and convert into small hydrocarbons. You need to remember that. Why do you actually convert the large hydrocarbons into the small hydrocarbon? If it is one of the 1 mark questions, you can clearly say that it's because about the supply and demand. Small hydrocarbons are more useful, large hydrocarbons are not that useful. That's why we actually convert them into the small hydrocarbons, and so we can use them in the daily life. Sorry, I couldn't actually explain that in the first part of the video because it was actually invisible. Basically, what I was saying is, when you have a large hydrocarbon and you're actually going to crack it by using steam and catalyst, it will be converted into 2 small hydrocarbons. Those 2 small hydrocarbons, one should be an alkene and other should be an alkane. And how are you going to figure that out? If you have a double the number of hydrogen atoms, and that is an alkene. If you have a double plus 2, and then it is an alkane. Now, in example, I was actually saying it that if they can actually eliminate this, and they said, can you complete it? So you should know you started with 30 carbon atoms, you have 10 there, so you will put out of 30, 10 are actually already produced, so you will say C20, and then because this is an alkene, so other product should be an alkane, so that is going to be 42. Now they can also do this way, they can remove this, and they can actually ask you to actually predict the starting material. So you combine them together, and that is pretty easy, which is C30H62. It is also very easy to predict if you do not remember the concept of alkene and alkane. If one product is already given, all you have to do minus all of it from this, and you will get automatically C10H20. It will automatically come in like that.